Team Arrow, Australia's premier solar racing team, has identified a problem with how cars today are used. Do you want to work hard and buy a nice, expensive, luxurious vehicle just to drive it to the train station every day, leaving it at risk of being damaged while soaking up the sun? No, of course not. It's a waste of your hard-earned money. You'd rather keep it in mint condition and enjoy your vehicle on the weekends. Team Arrow are going to draw upon their previous experience from dominant performances at the World Solar Challenge to produce a small, battery-powered, solar-charged vehicle for your daily commute. This removes the risk of your luxurious vehicle sitting at a train station all day being needlessly damaged, while giving you a cheap, convenient mode of transport that can recharge while it's sitting in the sun all day.
From a detailed analysis of the current market for electric vehicles, it has been identified that this sector has experienced exponential growth in the past few years, particularly in the European market, due to legislative incentives that have come out of the Paris Agreement. As Australia is also a signatory of this agreement, these trends are expected to transition into the Australian market. One of the previous barriers for electric vehicles entering the Australian market has been the cost of this technology. Team Arrow plan to use their previous experience to produce a much lower cost vehicle, bringing their vehicle to market at approximately $15,000. This will overcome the previous experience price barriers of competitors. They also plan to use solar panels as the charging infrastructure, making the previous issue of charging infrastructure a non-issue. To help bring Team Arrow's vision into reality, myself and my colleagues at CALS Design, Chris, Luckman and Stephen, have been engaged by Team Arrow to begin work to produce this vehicle for the consumers.
CALS Design's role in this larger, overarching vision is to develop a proof-of-concept prototype vehicle. This prototype aims to showcase and permit testing of the key technologies and design elements which define the proposed product. These significant technologies include the leaning suspension, steering, the chassis, three-wheeled vehicle dynamics, the electric drivetrain, solar recharging, and the ergonomics of fundamental internal features. There is no specified budget for the prototype itself. However, the aim is to minimise cost, and it is expected the prototype will not exceed the proposed product retail price of $10,000 to $15,000. This means the elements of the vehicle which are not vital to its critical performance as a minimal, viable product will not be addressed by CALS Design. As such, the prototype is intended to be a single-seater vehicle without a roof or doors. This significantly simplifies the design without interfering with the key features the prototype aims to validate, and leaves potential for this design to be progressed to a two-seater with a roof and doors in future iterations. Other superfluous elements which revolve around refinement and finer detail in areas such as the interior and external body shape will also not be considered. Additionally, CALS Design will not be performing detailed design of the electrical systems associated with the vehicle, as Team Arrow has an electrical team who specialise in this area and whom will be responsible for this aspect of the vehicle. General specifications of required electrical components will be addressed as required.
For the design of the suspension, I am responsible for ensuring the suspension system satisfies Team Arrow requirements. The suspension design need to be able for standard road use while being one of the X factor for the customer to purchase our vehicle. Ensuring the car within the ADR guidelines is our primary objective.
The suspension system would allow our vehicle to tilt while going into a corner, creating a more exciting driving sensation compared to the conventional car. The tilt is produced by shifting the vehicle weight to one side while taking a corner, which helps reduce the turn radius of the vehicle.
Working closely with the front suspension designer, my role in the project focuses on steering geometry and linkage design. Based on similar vehicles within the market, as well as packaging and simplicity requirements, a rack and pinion steering system has been chosen for the prototype.
While the core rack will likely be repurposed from an existing vehicle, much of the design exercise will focus on linkages to the wheel hubs and integration with the chassis and front suspension. The development of the steering system will also extend my project role into driver ergonomics, specifically relating steering column mounting and design, as well as component selection affecting steering dynamics such as tyres and wheels.
My role in the prototype vehicle development is the design of the chassis. The design of this component requires consideration of dynamic loading on the chassis, the interface with other components, and the weight distribution of internal elements and the chassis itself. Upon consideration of multiple potential design approaches identified in prior art, such as space frames, pressed alloy, and tunnel spine designs, it was ultimately concluded that an aluminium honeycomb monocoque was most appropriate. The aluminium honeycomb monocoque fits the design parameters because, when compared to the alternatives mentioned, it is low cost, very easy to assemble, is inherently corrosion resistant, is lightweight, and has been proven through varied applications such as Formula One and other high-performance vehicles to offer impressive structural rigidity and torsional stiffness.
The first stage focuses on prior research by looking into past designs and work done by people in the industry. We also try to find a sweet spot for team management regarding finding our roles and responsibility within the group.
The second stage of the project concentrates on critical design review. In this stage, we will need to liaise with client frequently to satisfy the client requirements and of the project. We will need to design the suspension and chassis component by modeling using SolidWorks. The model will need to be simulated to analyze the structural and mechanical integrity of the product using ANSYS. The third stage is to prepare a detailed design for the client and school. We will need to fabricate or manufacture our model for its testing and reiteration of the model. We will be considering suppliers and contractors while keeping the cost within the budget allocated. The prototype of the product will help us regarding our final design. The final stage is to finalize our design. We will need to present our finished product with a detailed report of the bills of materials, cost of production, and concept used in finalizing our plan. Future work to be done on the vehicle will be discussed in the report.
The aforementioned vehicle systems and components to be focused on during CALS design process will most effectively allow for the development of a minimal viable product. Project XOOM combines an assortment of modern and emerging technologies into a unique vehicle platform. As a result, a simplified prototype will allow for effective testing and iterations of a concept that is largely unseen before. These sentiments are shared by our clients at Team Arrow with the added benefit of a physical product to present to investors, increasing potential sponsorship opportunities.
The chassis, front suspension and steering system forms the basis of the team's key design roles for the preliminary stages of the project. These were chosen as they represent the most difficult design issues to overcome for a functional prototype. The chassis layout has a large effect on the sizing and specification of other components, as well as playing the primary role in meeting the client's safety requirements. The leading front suspension geometry is a complex and uncommon design problem which forms one of the main functional goals of the project. Lastly, steering design and integration incorporates a variety of vehicle components while also being heavily influenced by the vehicle's unique driving dynamics. The focus on these key subsystems will allow for the respective issues to be addressed with high priority and for CALS Design to start producing a working prototype as soon as possible. CALS Design is excited to continue development of our proof of concept minimal viable product and use this prototype to overcome difficult design challenges. With Team Arrow support, we believe the vision of an affordable yet exhilarating electrical personal transport solution is just around the corner.